Thank you very much. So I'm going to start it off today. I'm obviously with Telef. We're the first company for the day. My name is Carl Moberg. I know some of you from real life. I know some of you from the virtual universe. And for some of you guys, it's the first time. So thanks, Stephen, first of all, for having us. The agenda we have today is kind of audience driven, guys. So you guys will have to help out a little bit. Otherwise, we will not run over. We will run short. Hopefully, there's a couple of things here that will make you really upset in a very good way. So I'm just hoping that we are able to get to the point where you guys are screaming with joy and giving us good advice going forward. So we were asked to introduce ourselves. My name is Carl Moberg. As I said, I'm the VP Technology. That's just a sign of that I got to choose my own title when I moved here early last year. So what I do is some sort of an extended CTO role. I do a lot of standards work. So if you want to badmouth the standards organizations, I'm probably the right guy to do it to. And I also spend time with our larger customers. We have a couple of very large customers that need some attention from my kind here. So I'm going to talk you through the background of the company. I'm going to talk you through what it is we have, its moving parts, what people are doing with it. And the rest of the agenda consists of a demo and 2 deeper dives. And we can go extremely deep. I have my brains with me. I'm the beauty. These are the brains. So be nice to me, be mean to them. That's good. Usually a good distribution. Telef Systems is a Swedish software company. We were actually founded in 2005, so we've been around for a while. The first couple of years, we stayed in a part of the industry that very few people know much about. The first software that we brought to market is actually something that we sell into the equipment providers themselves. So it's a piece of software that actually end up on the routers and switches that you guys use. I'm trying to stay away from naming names here, but let me just tell you that if or when you log into kind of next generation or current generation hardware from some of the very large vendors, you will end up in Telef software, just that they don't tell you. So we started out with our heads under the hoods of literally every routing and switching platform in the industry. And this first product, actually called ConfD or Configuration Daemon, is something then again we sell into the engineering teams with these equipment providers. What this means to today's presentation, because I'm not going to talk about that product, is that you guys should think about us as someone or a company that comes out of the actual nitty-gritty of the software running on these network elements. That's where we got our start. That's what we've done for many years. We have 80 plus what's called design wins, so different projects in the equipment provider space. With my marketing hat on, 8 out of the 10 largest equipment providers actually use our stuff to some extent in parts of their portfolio. Big thing happened to us in 2009. We started getting really strong signals, both from our then existing customer base, the equipment providers, but also from some of the very friendly service providers and data centers that we knew, about the need for a piece of software that would sit in the middle of the network, that would hide the horrible complexity of whatever it's running, and provide useful interfaces going north out of it, aimed at both humans and applications. So we actually launched that. Our first paying customers in 2010, we struggled horribly the first year to explain what this is to network engineers. No, it's not an SNMP trap sync. No, it's not something that competes with OpenView. No, it's not a file storage for configuration. It's actually something you use to program your network, okay? About a year after that, the SDN thing came crashing out the gates, right? The whole blank slate project and its professors and high priests came out. We try to start the conversations these days by saying it's a controller and then quickly say, but it's not OpenFlow, okay? It knows OpenFlow, but it's not an OpenFlow controller. It is a multi-vendor, multi-protocol controller. And it helps because it kind of snaps people into the architectural understanding of where we are and what we do, okay? So we've been doing this since 2010, and of course much more details about this software, which is what we're going to talk about here today. So our target market for this kind of thing is basically any network of ambitious size that needs to get people out of the loop. So it spans the data centers around here, which is one of the reasons why I moved here, the large service providers, and actually some of the enterprises of the world. People that need to automate and programmatically manage their networks. As a side note, Actually, we have, since we started the company, spent, for a company our size, we're about 100 people, and again, we're in Sweden, the headquarters is in Sweden. We spend a lot of time in the standardization organizations, okay? There's a lot of need or want for experience around manageability in these SDOs, so the standard defining organizations. You may have actually heard about us in the context of NetConf and the Yang language. We have spent a lot of time there. We think in the long term that's going to change things around significantly in the industry, but we also understand that that's a very slow process. But we have my colleague Martin Björklund being the editor of the Yang RFC, and Yang is certainly something that we see taking off, and it's a key technology that we will talk much more about for our own software. I spend quite a bit of time in the ONF. The ONF, as you guys know, is the organization that's herding the OpenFlow standards. Now, I care less about the OpenFlow wire protocol. I care much more about something called the OF-config protocol, which is a way of managing virtual switches, or the lifecycle of virtual switches. It's kind of the same thing as OVSDB, if you like, where at least there's a lot of overlap between them. Just that OF-config happens to come out of the ONF, OVSDB comes out of an open source project. A lot of things happening around NFV, this vague term, network function virtualization. TeleF as a company was part of a proof of concept 2 years ago inside of British Telecom that eventually turned into something that they briefly called the Carriers Club, which was a very bad name, and then they found their home in Etsy. So we were part of this process leading up to the network function virtualization efforts inside of the Etsy ISG NFV. And we care mostly, as you can imagine, about management and orchestration. And then we have historically done a lot of things. We, of course, like any good industry citizen, we have a plugin for the OpenStack Havana. We have spent some time in the TM forum for our more service provider-oriented customer base. And I've actually spent quite a bit of time in the MEF for modeling stuff, for Yang modeling for particular parts of the MEF standards. So in general, we spend a lot of time in the standards organizations because we think there's a whole lot of things that needs to be done here in a way that people can use and reuse between them. And of course, we have our own set of open source tools to back this up. So we try to get it widely used and widely abused. Just very briefly, and I know most customers or most people in the industry hates being told their own problem, but here's our brief reflection. I used to run networks in the 90s. None of these things were very much around at that point. We only transported bits and bytes. There's a lot of things that people want to do with the networks these days. There's 3 things that are emerging that really affects the operations teams that we've talked to. The frequency of change in their network is going through the roof. Okay, the amount of time they spend changing stuff, or the frequency of those changes, is through the roof. The complexity of each change, the amount of knobs you have to twist on each end of things, is scary. And even worse, the cost of failing or delaying these changes is also something that is a concern for most operations teams. So they are kind of the 3 pain points that we find people complaining most loudly about. Frequency, complexity, and cost of failure. That drives people to actually want to change things. And of course, this is what network configuration looks like today. And I've been traveling since I moved here about a year ago. I've seen awful, awful, awful things in some of the largest and most high-profile networks that we have in this great nation. There's usually 3 moving parts. There's a huge amount of network engineers growing if they can. There are configuration file backups. And then there are configuration scripts that some of these guys or girls wrote. That's what you get, right? And again, it works great if your frequency change is low or going down, and the complexity of each change is low or going down. And actually, what if, who cares if we fail? We can fail or delay, that's fine. Zero networks have these constraints or these kind of counter constraints. And I think one of the MSOs that I talked about said it nicely on their Ethernet operations. This is not a bump or a brick or something that we have to fight a little harder to get through. It is a brick wall, right? If we don't do anything, we go out of business. This is a huge problem. And we've been going around with this product for about 4 years now, right? And the first year, I literally got into rooms with the operations teams. You had the VP operations on one side, and you had the key engineer that actually wrote those scripts on the other side. I did my song and dance. That's much what I do. And the key engineer who owns this script said, we can do all of that, which was a huge, blatant lie. But it's really hard to say that to him or her in front of the VP, right? because if that person really loves running these scripts, it's going to be a non-starter for a solution like us. Fast forward to about 2 years ago, go back to the same table, same people. That person is now scared out of their wits because their piece of configuration scripts is now part of their revenue stream. They get new requirements coming right from product management, right from the CTO or CIO, on a set of scripts that were never meant for wide deployment. So that person has now a complete change of tone, saying that actually, and what I'm going to show you here could be a useful thing. So we can focus on what it is we want to do, not how we want to do it. And my observation is that that's changed radically over the last couple of years. Non-starter 4 or 5 years ago, people actually pull us in at this point. And I try to make this point over and over again. Make no mistake, this is the #1 market leader in network configuration. It's accompanied by its friend, the Excel spreadsheet, and the printer. The biggest service providers in this country prints work orders, walks over to their share and types into the router what it says on the printed work order. If these work orders come out in the wrong order, things break. It is a horrible situation, right? Don't let anyone tell you anything else. This is the #1 incumbent. This is what we are as a company going for. We're going to replace that thing. How do we do this? Here's the product. It is a piece of software. It sits in the middle of the network. You will recognize most of this. Below it, there's usually a combination these days of physical hardware, virtual appliances, and the virtual appliances that we see today is literally the same operating system image that used to sit on gold-plated hardware that's now in a hypervisor. So nothing particularly exotic about these virtual appliances. We have fairly recently gotten real requests for actual operational OpenFlow. That happened about a year and a half ago. So we now know of people that are actually trying to put this in wide deployment with various degrees of success, let me tell you, but it's out there. We use a wide variety of protocols to talk to these network elements. We use what they have, okay? No waiting for flag day, no waiting for protocol version this or that. We started out with netconf, which is at that point was Juniper, and the Cisco CLI. That will give you about 85% of the market. If you can manage things using the netconf protocol or the Cisco CLI, you have a play. Then there's a tail, a long tail with SNMP, REST, talking to other EMSs, things like that. But that's largely where it is today. North of this system, or on top of the systems, there's usually a combination of management applications and network engineers. Management applications is things like workflow engines, WAN orchestration tools, self-service portals, any piece of software that wants to talk to the network as a coherent asset and cares about the configuration of it. Culturally, in order to get into networks, these are the ones that you have to convince. Okay? People running the network, loving the network elements. So there's a wide variety of features here that allows network engineers to kind of keep working the way they do. So we have a Juniper style and a Cisco style CLI, for example, that we will show in the demo that will allow them to still use the same look and feel. It's just that they will now talk to the network as a whole. There is two things that sets a system like this apart. We're careful Swedish software companies. We made sure that we actually had something to show, and we weren't too much of a me too. First of all, we drive the system entirely out of YANG models, out of data models, right? So if there's no YANG models loaded, it's a glorified letterpress, does nothing. It is not a system that's specific to VPNs, firewall rules management, or BGP policy management. We have customers using it for each and all of them. It's all guided by which models you load and how you want to use it. It's not a point solution. Device layer, we use YANG files to describe the syntax and semantics of the southbound protocols. So if it's a Cisco CLI, this is an accurate reflection of the labels, syntax, and semantics of the Cisco CLI. If it's a Junos box, same thing, just that we use YANG for it. Service layer depends on what your network does, right? For traditional service providers, point-to-point VPNs. For data centers, a VM, moving with a service chain. For other companies, like enterprise companies, firewall policies tied to point of sales terminals. So it depends on what your network do. Express that in YANG as well. And if you have both layers in a very formal and detailed language, YANG is very formal and detailed, can explain structures. It understands the syntax of an IPv6 address and the difference between 32 bits and 64 bits. The problem or the challenge of any of these systems, which is the decomposition step between the service and device, becomes very small. very small and very tractable also for people that are not programmers. So the point of this thing, of course, is to have a service-to-device decomposition layer that's useful for both engineers and management applications, and that doesn't require much programming. Because then we can go in and ask, what is it that you need to automate? And then the same day show them this is what it would look like. Independent of whether it's L2, L3 VPN or L4, L7 services, service chains, many other things. And we'll talk again more in detail about this. The second thing, apart from the modeling, is transactions. Transactions is the kind of vague promise from the system to any of its user, network engineer, or application that either the entire change that you're proposing happens to the network, or we will be back to where we were before. We will not leave you in an inconsistent state. It's a fundamental aspect of building trust, first of all with the network engineers, but also with the application programmers, that what you are actually editing here is an accurate reflection of what's running in the network. Really important. It also addresses things like not if, but when someone changes the configuration of a router or a switch that's supposed to be managed by this software, we can find that out and we can allow people to remediate in either direction. Either say that's a great change, we can pull it in, or that change actually break these 5 service instances, let's roll it over. You need transactions for that. So like I said, data models. So we also use data models, which are very formal, to drive the northbound APIs, right? So if you add a new device or add a new version of a device, which is a huge challenge, the northbound APIs will follow. Because if you think about it, what you use the northbound APIs, the REST interface, the Java interface, the netconf interface, is to get to the data in the database according to the schema and change it and push it back to the network, okay? So if you add support for a new device, you don't have to change anything or program anything. If you add a new service or change a new service, no programming, nothing. The northbound interfaces will follow. Huge, huge change from how people used to do it before. Like I said, transactions. Actually, the interesting part here, again, we're a software company, so we know this from before, but it's distributed and atomic change sets, which is the key. And these are the one things that I hopefully will spin your heads when we explain how we do that across things that don't come very natural to atomic change sets, like the Cisco CLI. And I'm just going to show this and briefly say it, because obviously after any first meeting, people ask about scalability and high availability, right? We have an over-engineered scalability and performance environment here. And what people ask first is always, how many devices? That's not the problem. We've shown actually for a Swedish company that builds telephony systems how to do this on 120,000 base stations from a single node with NCS. Node count is not the problem. The problem is complexity of each change. How deep and complicated is the change that you send to the network? And latency, actually the turnaround time from each of the devices that you touch. Especially with high-end routers and switches today, it can actually be in the tens of seconds, which if you're planning to do tens of thousands of service commits per hour, will drive massive parallelism, right? And massive parallelism has a consistency side effects. So it's rather these two than node count. That's the problem for these things. And HA control, actually making sure the master, who's the slave, things like that, is usually very specific per customer. So we are a good process citizen for that, but people actually solve that with things like BGP or expensive middleware, so it kind of depends. And some of the largest networks that we're in today is actually rolling out over a couple of tens of thousands of devices. That's about what service providers today have in terms of administrative domains. So a couple of tens of thousands of devices, not ports, but devices, is about where the administrative domains, the organizational boundary starts to hit. So it makes less sense to actually have a single system managing larger networks than that. And the second thing they ask, of course, is who do you support? Well, one of the things that we're going to show you is that it's trivial and very fast to add support for new vendors. So here's a snapshot of the vendors that we have been working with, and there's bits and pieces of it in deployment. And actually, I usually say this, that it's not the vendor that's hard, it's the protocol that they chose to implement in their box, right? So some of these use Cisco-style CLI, and we have a great support for Cisco-style CLI. Anyone who uses netconf is, of course, right off the bat for us, right? Because we have netconf in our system. And then they start saying things like REST. Well, REST is an architectural principle. What do you mean? And then it starts to get hairy, right? Because then you actually have to manually implement things. So it varies across choice of protocol more than particular vendors.
And is that something you guys are taking on in terms of adding that new support for vendors, or is there a mechanism for your end customers to kind of add that abstraction layer of their own to translate a given command to vendor X's, RESTful API command, or how does that integration of new vendors work?
We're a fairly small company. Our customers are usually orders of magnitude larger, so we don't get to say. We have requirements for each end, right? We have requirements from, we don't want to see these network equipment drivers, you guys figure it out for us, all the way to give us the SDK. And we are very happy to give them the SDK. Actually, we think the market is going in that direction. As soon as we can get out of the CLI thing, and things can be model driven, there's no point to be in this extreme end where we do things. And most of the ambitious customers that really take this on automation, they want to own it. They hire people that take an interest in these things. And we want to go in this direction, but of course there are still customers that say, no. We want this to be a black box. You guys figure it out. We'll let you know when we upgrade. And we just expect it to work.
Okay. Thanks.
Of course, the point of this thing is agility, right? So there's actually 2 layers of agility that we go for. First of all, it's services, right? One of the biggest complaints we get from people that actually run and sell services in networks, be that data centers or be that service providers, is why does it take people 12 to 16 months to give me a new bandwidth tier for my VPNs? Why does it take them 2 years to add a firewall service to my service chain? Of course, what we want to explain to them is that actually if you do it in this fashion, it's straightforward because we've taken out all the scaffolding and you can focus on the service and how to implement that. So we can actually show them with 100 lines of YANG and 300 lines of XML template, you can set up an MPLS L3 VPN service, which is usually in a day or 2. And this is, of course, what we demo for our customers, how to do this in your network in a day or 2. And the second thing, of course, is that as you guys probably know, most of the people running ambitious networks wants to get away from vendor lock-in, and EMSs and management from particular vendors is the traditional way, or one of many traditional ways of locking in, right? So they want us to show how, if it's inexpensive and fast to add support for new devices. Same thing here, and this is actually going to be part of the longer presentation. Use YANG to describe the device model, and then depending on the protocol, we probably have it. And we have something called NEDs and the NED algorithm. So this is usually a couple of hours and also something that we usually live demo for them. Show us your network. We will develop the NEDs while we're there, and we'll show you how to set up a service for it. There's a lot of other things in this system. It is never deployed standalone, right? There's a huge amount of APIs. It usually gets integrated into workflow, like I said, traditional OSS. We are never going to be a traditional inventory system, so there's usually someone around us that will integrate with this. We are never going to be an IPAM system, right? So there's usually some sort of an asset manager, stateful or stateless, that this thing picks stuff out of. AAA is actually non-trivial but very interesting here, because if you have role-based access control over the full set of configuration, both of devices and services, you can do things like junior network engineers can only see customer-facing Ethernets. Super engineers can see the entire BGP configuration. Customers can only see their own service, right? They can't even see the actual configuration of the network. So it's an interesting thing. This is all driven by packages. We'll talk a little bit more about that in detail. So the way you load new support for devices, the way you load new services and update services is through a package framework. There's 2 ways of doing the mapping logic between services and devices, and it kind of depends on the culture of the customer. Some people really like to do this in Java, so we have a mapping logic environment in Java. Some people like to do this in templates, things that look kind of like XSLT, and then you can actually do that through your CLI. So you can start playing around with the service models in the CLI, which sits nicely with them. And actually, kind of this part of the architecture is actually testament to when I get the question from analysts and journalists, who's your main competitor? I always half-jokingly tell them that it's the cynicism with the network operations teams. That is literally our biggest threat to the company. Because as you can imagine, when we get into the first meeting, we kind of tippy-toe past the labs usually, right, into the operations teams, because we want to hear what the network is actually suffering from, not what they're thinking of 10, 15 years in the future. They're always leaning back like this, right? You get 15 minutes. And all we can do in the first meeting is to have them lean in. I see some of you guys are leaning in, which is great. That's about as far as you go in a first meeting with people that have battle scars and have, I'm not going to name names, but have licenses of other software solutions lying around the back of the room because they never made it into production. So cynicism is a big thing. And of course, giving usually the network engineers transparency and a choice of their own, of the tools that they want to use, it turned out to be huge for us. Something that we as a technical company maybe didn't think so much about in the beginning, but certainly was pointed out to us repeatedly by the customers. Okay, so I'm just going to briefly mention a couple of customers. The one that I think maybe some of you have heard to death already, and why it's amazing for us is because it's a big one, right? And they are doing things somewhat differently. It's Deutsche Telekom in their TerraStream project, so they allow us to talk about it widely, which is good for us. Very interesting for those of you who hasn't looked at it. Look at it. It's an IP person's dream. It's driven by very colorful characters inside of Deutsche Telekom. They're doing two things. They're doing very upsetting things on the optical layer. They're building a transport network that's entirely void of optical subsystems. So no SDH on it, no DWDM. All passive, coherent 100 gig optics between L3 boxes, which you can imagine the impact of a company the size of Deutsche Telekom when you start thinking about that, how much smaller the organization and budget can be in the long term if you don't have to do SDH Sonnet and DWDM. I don't know so much about that, but I know people really love it. The second thing that they're doing is that they're using us as what they call the real-time OSS. So they want to build a completely hands-off network. Changes mid-flight in this network is only supposed to come from customer services, driven through NCS, so we make all the changes to the participating network elements. And we're actually trying to make it completely also void of break fix. We're trying to go towards the fact that we can have n-way redundancy, maybe 2 or 3, so we can actually switch out the faulting network elements instead of logging into them and trying to fix them, okay? So hands-off is kind of the idea here. It's very forward-looking, very interesting. I recommend looking at some of the presentations that some of the key engineers in this project have done. They have opened up widely because they want the rest of the world, the service provider transport world, to do this. And of course their point here is to take down the cost of producing bandwidth, because they know at their scale they will start losing every business they have in a couple of years unless they come down quite significantly in the price here. Another thing that comes around quite a bit is VPN provisioning in all its shapes and forms. People don't want to type in, and some of you guys have blogged about it, don't want to type in VPN or VLAN commands at all anymore. You know, it's not the least exciting, it's error prone and things like that. So of course what we're doing with some of our customers is to do, again, multi-vendor. This is key, right? Because this needs to work on their existing networks, and they also have a couple of billions of dollars of hardware already sitting on the shelves that are about to be shifted in. So no room for major reshuffling over the next couple of investment cycles. So just point-to-point and point-to-multipoint VPNs with multi-vendor support is a big thing for many of our customers. And of course, API integrations, customer self-service portals is one of the ways that the service providers is trying to get out of the OSS deadlock and close the loop with the customer, so it doesn't have to go through this deep and very fragile stack of OSS systems. One thing that comes up quite a bit is this new vague term called service chaining. My take on service chaining for this presentation is to grab traffic and direct it through an ordered set of ephemeral features or functions, right? This customer wanted to use PK8 switches, open flow, capture data, and drive it through an ordered set of things. This is a logical worldview. Actually, the traffic is going to go back and forth through the switch. But you see what I mean. Now, the interesting thing here, of course, is that they want to use this as an upsell. So they have point-to-point solutions today, but they want to go back to that market and say, you know what? With a click of the button, you can now introduce a firewall. And you can introduce a DPI. And you get full flexibility in configuring these things. So for us, for NCS, this becomes a multi-protocol, multi-technology, multi-vendor problem. Several load balancer vendors, they want several firewall vendors, several content filtering vendors. They don't have OpenFlow. Some of these will never grow OpenFlow. Right? So you can talk OpenFlow to the directing switch, but then you have to talk a wide variety of good and bad protocols to the participating network elements. Service-oriented, stable northbound, right? So independent of whether you completely switch out your next to favorite firewall vendor, the service API shouldn't change. But it also needs to include the actual application configuration, the firewall rules, right? So that's the challenge space here. And of course, this is an interesting kind of first stab on it, and it's actually a customer coming out of Asia. And it will be interesting to see how they can eventually make this work, not so much because of technology, but in terms of shipping and selling this to their customers. We didn't know that going in, but firewall rules management, especially in companies with multi-vendor strategies, pairs of firewalls from different vendors, different versions going back and forth, seems to be one of the strongest factors in why, for example, I lose a mobile telephony now and then when I travel. The war stories we've heard from these firewall managers is awful. It is an abomination the way this works, right? And this is because they need both vendor manuals, even if they do the most slightest thing, right? Well-known thing. And there's pacing and ordering, and there's a lot of different things. So we're definitely being called on to not only do the point-to-point provisioning, but also up the stack. And this really, really sticks out. The firewall rules, capabilities, and policy management. Okay. So actually, I have 2 more minutes on my slot. So I'm going to actually just go through these. Don't know how much you guys care about NFV, but there's certainly a big upset around about where I live, which is here, around how to go about NFV. And I'll just share an observation. This is the end-to-end architectural from the Etsy NFV. And the one thing that really sticks out to me, I don't know if you guys haven't cared as much about network management as I have, but that really sticks out here is that you'll see that there's a vendor-specific EMSs also in this bright new feature where you bring up virtual networking functions. You're supposed to also in some way, shape, or form bring up a vendor-specific EMS. The POCs that we are in with some of the major service providers realize that this is a huge non-starter. Right? We can't do that. We need something else. Because otherwise the combinatorial explosion for the orchestrator and for some of these what's called the VNF managers, when they need to talk to the VNFs, is going to be awful, and it's going to be directly tied to the amount of vendors that we have, which is kind of a function that we need to get out of. We want better freedom for vendor selection without impacting operations. So the way we're being used here is as a kind of southern part of an orchestrator, top part of the VNF manager, and certainly something that the OSS BSS talks to towards the virtual network functions, or the routers and switches here. And all I want to say about this is actually the way I would like you guys to think about this, and of course the way we believe that our customers think about it, is that you need something like this to transition from where we are today, which is again largely hardware based, into a future that may or may not be completely virtual network function specific. And with NCS, of course, you can have a stable, service-oriented, northbound API. So at least that part, you don't have to care about so much. And you can start it right away. And another question that usually comes up is, where are you with OpenStack? I'm going to just mention that as well. As I said, we took the faith-based approach that we would actually upstream our things. So we built an ML2 driver for Havana, and we made it in. It was quite an interesting trip there. So we actually faithfully represent the REST interface coming out of Neutron. What we like to think is good with this, and what our customers like to think is good with this, is that you get to choose the vendors, right? This is a vendor-independent ML2 driver. We have, as you have seen before, a wide variety of vendor support again, and you can actually also push down the technology choice, so whether you to use VXLAN or anything else, it's actually now part of what's below OpenStack. And of course the HA and many other things. So the way to think about it is that it's a great plug-in for networks that change quite a bit, and where you want to do the technology choice below OpenStack. Interesting ride through the review process, but we got it in. And of course the big thing here is that it doesn't really change anything on OpenStack, right? Again, we faithfully reproduce the somewhat constrained worldview of Neutron, but that's, there's not much you can do for that right now, except trying to help OpenStack to kind of move away from that. So trying to stay close to that. So that's half an hour of introduction. One question. I didn't upset you guys enough. That's that.
So I just wanted to comment. I see a lot of similarity between NCS and Open Daylight, because the biggest part of this whole northbound API is because you don't want a change in your infrastructure to impact operations, right? So you provide that abstraction northbound, and that way you don't have to change when things get swapped out. I do notice a difference on the description of those network services, like through Yang. Do you have any comments on like the direction, I guess, between your NCS product and the way that Open Daylight's developing that? Because there's no standardized northbound API right now.
Right. Couple of observations. I mean, the one thing is that we exist, which is huge, right? Only half joking, right? The second thing is that there is a it's so hard to comment on open source projects because it really depends on where they're going with it. It's really hard. Yes, there's similarities. Yes, we regret some of the presentations we did 2 years ago to some people. We'll see. We'll see. We have actual integration strategies, and I mean, Open Daylight is going to. Had you been in a customer meeting, I would have asked, who would you buy it from, right? Or do you have a staff that would do it, right? So depending on who you buy it from, the story is going to be somewhat different. If you buy it from any of the incumbent hardware bending vendors, they will sell it to you in one fashion. If you buy it from any of the software giants up the peninsula, they will sell it to you in a variety of different ways, right? So we'll see. We'll see. There's a variety of ways we can integrate with Daylight, both as a open flow controller down here. See what I mean? So Daylight would be here.
Could be.
Could be. Depends on who sells it and what they want to do.
Well, the benefit is I see that you guys are taking advantage of the benefits in that kind of an infrastructure. You have that abstracted northbound language that doesn't have anything to do with the devices down there.
Right.
The benefit, obviously, being that you're a company and you can support companies that decide to implement.
And that's the kind of qualitative side of things. And then who knows? And I know there's a lot of big companies that have big plans for it for their particular purposes. Some of them will tie it to their own infrastructure. Some of them will try and attack the multi-vendor side of things. So we'll see. We'll see.